Welcome back. I hope you have enjoyed lunch. And right now we start fresh. Emily Stamey here with us, another lady lecturer from the US. In this conference, Emily is a software engineer in North Carolina and works at Inquest, a network security monitoring company. Emily, it's your time.
Thank you. That was much louder than I expected. Hi, I'm Emily. Thank you very much for having me. I'm really glad to be here. I've really enjoyed visiting Serbia, so thank you very much for having me. I'm from North Carolina on the eastern part of the United States, and I really like developer communities, so I participate in my local PHP community called Triangle PHP. And I'm an organizer, a director with Women Who Code, which helps women in software engineering positions connect with each other and build up our networks. I've been developing PHP since about 1999, and I've spent most of my development career in the PHP space. I used to work for a university. 2 of my examples are going to be from that university experience, and I currently work for Inquest, a network security company. Before we begin, I want to talk about how making a switch from a framework into event sourcing is kind of a rough transition. And a lot of times we feel like we need to just understand it right out the gate. And that's not an easy thing to accomplish with event sourcing. It's more of a process. So be patient with yourself, as you always should be when you're learning something new. Also, event sourcing isn't for everything, and it's not for entire applications, but it has really helpful tools, and it can be really useful for some things, for a lot of things. So we're going to talk about just the basics of how the pieces of event sourcing work together, and we're going to talk about those 3 projects that I have for examples that solve some existing problems. The basic idea of event sourcing is that you're recording a thing that happened, and the sequence is really important. So you want to keep track of the order that these events happen, and you're always recording them in their proper order, and you're always playing them back in the proper order. You don't vary from that. And an event is a thing that actually happened. It's not a thing that might happen. It's definitely something that has happened in your system. And then we'll have these listeners. You'll see these little ears. I'll always represent the events as these red diamonds, and these ears are the listeners when we're talking about the thing that's going to subscribe to our event. And it has certain things that it does when it sees the types of events that it cares about. So an example would be if you were checking out books from a library. An event that would actually happen is that a book was checked out. And you would care about who checked out that book, what book was checked out, and when did it happen. Those would be significant pieces of information about your event. But you're only going to save what you absolutely need to preserve. It's the specific, more time-sensitive details about that event, because the rest can be looked up. So we're only going to store the ID of a patron and the ID of the book and the date, instead of the entire object. And there are a few rules that you want to keep in mind about events. They're usually named as past tense verbs, like our book was checked out. They're rarely changed. They're never deleted. And those attributes are values, not objects or aggregates or anything that we have to reconstruct. But let's talk about why we never delete an event. The reason for this is that your event store is a history of your application. It is your audit log of everything that has happened in your application, all the events that you want to record. If you were to go in and delete parts of your history, then you would undermine how reliable that was. And Greg Young, who writes a lot of the material that you'll read about event sourcing as you dig into this a little bit deeper, he makes a point of saying that he could never find a picture of an accountant erasing an item from a ledger, because that's unethical. To go in and make a mistake and then erase it would be wrong for them to do. And you want to think about your event store in the same way. But accountants do make mistakes sometimes. They might typo a number and put an extra zero in. So if an accountant made a mistake that was like depositing $500 instead of $50, they would issue a correction that was the exact opposite of what that mistake was. Because when you're looking in the ledger and you can see those events that basically cancel each other out, it's a lot clearer what happened. And then they'll issue an event for what they actually intended to do, to correct the mistake. And also along the lines of the sequence of these events, depositing and withdrawing money, the order in which those things happen is significant, because if you withdraw the money before you deposit, sometimes you'll have an overdraft, right? So you want to keep in mind that that sequence is really important. I also said that we don't store objects in our events. And part of that is because we want our applications to be flexible for changes. We want to be able to let that behavior of our application evolve the way that they always do. But if we had something like Object 1 that started out having only 2 attributes, and we decided to add a third one, but we had stored that in an event, we would have a little bit of trouble unpacking that. And it's not that it's impossible to reconstruct that older version of the object. It's just that we are writing into our event something that should be flexible to change. And it's not that we can't deconstruct that earlier version of object. It's that we want to capitalize on what is beneficial of events. So just because we can doesn't mean we should. Events rarely change. When we're thinking about the events that are happening in our application, there are points in time and things that specifically happened. Usually when you're thinking about an event, you can think about what's important to that event, what's relevant, what's likely to change. But the behavior of our application, the way our users access it, and the type of information they want from our applications is likely to change. So using event sourcing helps you capture that history, but keep the rest of your application flexible for change in the future. You've still recorded that item in history, and you can always use it and access it, even though the way that you want to access it may change. And we'll talk a bit about that. So like I said, we have our event, and we have the listener that listens for that specific event. It has an apply method that knows exactly what to do whenever it sees that event, and it applies it by following those steps. And it generates some result. And this will happen with all of the events in your application. You can have collections of these listeners applying events and building up the information that you need to know in your application. But if your behavior changes, you can change what happens in that apply method. You can change the steps that you're going to follow and generate completely different results without having changed that event, which is really powerful. You've kept your history intact, and you haven't had to do these convoluted changes to your database. You've just created a new set of steps to follow and reapplied the events. You can also have 2 different sets of listeners that are thinking about those events from entirely different contexts. If you have students and maybe professors who look at that same event of asking for a class, requesting to take a class, they care about that event in different ways. And so their apply methods can be different, they can be unique, and they can generate different results based on the same thing that happened in your history. So events are important and very, very helpful because those state transitions are important. We want to know the history of our application, and we want to be flexible to changes without having to rewrite all of our history. Those events are always replayable for the entire lifespan of your application. So you can change big chunks of code without affecting the history of your applications. I like to, in my event store, wrap the event itself in a domain message. So you can save your event with its attributes that you care about, along with the timestamp, any unique identifier, and the type of event that it is. You can store them just like that, it's fine. I prefer to store them using a domain message, and I think about this blue circle as the envelope of my event. It just has the details of what type of event is contained, what is that unique identifier, how do, the date and when that event happened, and then the payload of that domain message is the event itself. So it separates the event from those specifics, but either way is fine. So my event store would look something like this. Oh, sorry. Sometimes I get overly enthusiastic. The event store, my event store would look like this because I'm storing my domain message and then the payload is the event itself. And that sequence of these events and when they happen is important. And my listeners are subscribing to the events that they care about. And they're all listening to this event store. We also have these projectors. This is where a lot of our listeners are going to be in an event-sourced application. And they have the apply methods. In this example, my projector cares about the first, third, and fourth events that are happening in my store. And it only pays attention to those. When it gets to the second one, it skips right over it. It just goes right on. And it has different apply methods for the different types of events that it cares about. And based on the steps that it follows in each of those apply methods, it builds our result, this table, and we call it the projection. It is the result of all of those events that have happened in this context. We also have a read model that does a lookup from that projection. So this is our same table that we just generated from events. And it has some queries to look up. If this was our checking out books example, maybe it's looking up what books are available to be checked out, or what books has this particular patron checked out. And so it has these queries to look up the information from the table and return those results to the users. It's really, really helpful because it's the results that you've generated from all of these events, and it can always be up to date. Sorry, my slides are a bit off track. So the event is only created after some sort of validation has happened. You don't record something in history if it's a maybe. This is something that's actually happened. So for things like checking out the book has to be available, doesn't it? It has to be on the shelf to check it out. And the person has to be allowed to use the library. So we make sure that the person who wants to check out the book is allowed, and we make sure that the book is available. And as long as that has happened, we'll check out that book. And so you can do it directly in your controller method. Once you've done your validation, you can create a new version of that event class. And you can also do it using commands and handlers. Something along these lines. So you have some interaction with your website. It routes it to the controller. you can have this command, the checkout book command, that providing the validation passes, you create that event, the checkout. The book was checked out. And you may be able to see the verb tensing changing just a bit in that. So CQRS is often listed alongside event sourcing, and it's pretty helpful and powerful as well. It's where you think about separating the commands and the queries from your application's behavior. And the command is anything that's going to make changes to state. So the command is going to generate that event and eventually make some changes to the state. But the query is more like your read model that's doing the lookups. It's not going to alter any information, it's just going to present it in different ways. And when you make those separations, you have some power because you can optimize your application for reads and writes. And you can balance your servers differently if you've made those distinctions. But you have to make them in your code and the behavior. But it's not necessary in all applications, as with most things. You don't have to do this everywhere, but only where it makes sense. If you've got something that's really write intensive, you might want to separate it. So we have command handlers. We have this command, checkout book. It's a lot like the event, where it has certain attributes that are passed from your request object, and the handler knows what to do with that type of command in order to validate it. It's only touching one entity, really. It's got a singular focus for this behavior. So first, you're validating that you can make this change, validating that the command is a valid command. And then if all that validation is successful, that's when you create your event. I really apologize, I keep having to look up here. This doesn't look anything at all like what I've got here. It's really distracting. So like I said, separating these commands and handlers allows you to optimize a lot of your, the way that your application operates. And you're making choices based on your application. Do you want to stay with a simple CRUD interface or behavior in your application, or do you need something a little bit more? A lot of times you'll be able to figure out where things don't quite fit, when it starts feeling really forced, when if you were trying to update books all the time to manage whether or not they were checked out, that would start feeling unnatural and contrived. You would have a lot of extra methods to make specific types of updates to that book to manage all of the checking in and checking out. And it's where that starts feeling hard, is where you might want to look at event sourcing. But there are a lot of other things to keep in mind too. We're going to talk about 3 of the projects that I've worked on, and the last one is one that I'm working on currently. The first 2 are from when I worked at a university. And I'm not sure how your universities are here, but most people who haven't worked in a university, at least in the States, think you're working with the newest technology, it's cutting edge, and what it really actually is that you're working with a bunch of technology pack rats who don't want to throw anything away. So you end up with a lot of legacy and a lot of really interesting challenges to help improve. The first one is a scholarships application. I worked for the College of Engineering, and they were distributing scholarships to engineering students. And so we worked on that application. There was also another one for students who weren't on campus to request classes. And so we worked on this course registration application. And finally, we'll talk about this project that I'm working on now at Inquest, how we're making some improvements using event sourcing. Scholarships was really interesting because it had been around for a really long time. It was mostly built by students, and it was using an early version of CodeIgniter. It was built by a person who didn't know what MVC was supposed to do. So it had a very large app model that included basically all of the functions that you would use in the entire application. But it had really important behavior. So students would fill out applications to say important details about themselves so that they could qualify for scholarships that would help them pay for school and help them stay in school. This was super important to them. And we had the engineering foundation, which kept relationships with donors to figure out, to try to encourage them to donate money to students and to help manage the money in funds that would accrue money for the students. Then we had our selection committee who would meet whenever there was money available, look at the students in their department and try to figure out who was the best qualified student to get the money. All of this was really important, and then at the end of the year, they would report that information to the financial aid office to say, these students will get scholarships at this time. And we were really just trying to fix a few small things in this application. And it was the first thing they gave me when I started this job. I think it was about 5 years ago. And I was just gonna squeeze it in just in 2 weeks over the summer. And I opened up the code base and it looked a bit like this, where it started out being a knife and then they decided they needed a fork and it was a big mess. So I'm sure that you've had something similar to this. And there was no version control. There was nothing that was testable. It was not using Composer. There were a lot of things we had to do before we even got started. So we finally talked them into giving us a little more time to do it the right way. We also discovered that there was a lot of functionality that they thought was working, and it wasn't. So it wasn't doing the thing they thought it was supposed to do, and that was a real problem. So we started out, like I said, with this older CodeIgniter application with just models, views, and controllers. And those were pretty straightforward. But the code was so risky to change that we decided we would preserve this and we wouldn't touch it. We weren't going to make any breaking changes to the schema. So we could add to it, but we couldn't delete things from it. Because this application was being used throughout the year, if we were to make a change to something in the student side, we might break something in the selection side and not know about it until the selection committee started using the application. So it was just too risky. So we decided we were going to leave that legacy application untouched and find a way of adding on to it. And we wanted to create bounded contexts because each of these people, each of these groups have different concerns in the application. They're doing a lot of the same things, they're working from the same money, but each of them has a different context. We were also thinking it would be really fun to try DDD, so we went all in. Super tight deadlines and brand new way of coding everything. It's a great idea, right? So that's what we did. But the way that we were able to make this work was that we created a new code base alongside the existing code base. So you may be able to see that we have this source folder, and that's where all of our new code existed. And we were able to give it namespaces and reference those namespaces by using Composer's autoloader. And then we created our bounded contexts for foundation, selection, and the student application. There were some things in common, so we had those in common, and then database type connections were under support. It was fairly straightforward, but basically, these are two entirely different applications that have no awareness of each other right now. And we were adding in event sourcing as well. So we have all of these events in our event store, and we decided we would keep that shared. So even though I told you we had these bounded contexts between our different groups, our event store was shared. And the way that this works is that a student knows, from the student domain perspective, they know what validation needs to happen in order to create the event that a student applied. So they maintain all of that logic for the validation and then the creation of student applied. But the selection committee cares about that event happening because they want to know this student is available to consider for a scholarship. So the selection committee wants to be aware of that event. So that's why we have our event store in the middle. We also had our foundation, which would have money become available when new money was deposited in an account. The selection committee also needed to know about that so that they could start considering those students and awarding money. So our event store was shared, but each of those bounded contexts held the information in order to create those events. And then the other bounded contexts managed what was significant about that event to them. And the ones they didn't care about, they ignored. Oh no. Okay. So this isn't showing, it's skipping stuff. All right. So in addition to namespacing that new set of code, we decided that we would create all new templates. We didn't want to relearn how to do older CodeIgniter templates. And we wanted to try to make as much of what we were writing today or at that time be able to go with us in the future. So we started out with Twig for our templating. And then anytime we were ready to replace a section of the code, we created a new controller to manage that new code. And we would just kind of lock people out of the old controller or those methods that were no longer relevant. So we would retire it in pieces using this technique. And that new controller would access our new commands and our new services and build that presentation layer with Twig. And the way that it became aware of those was using dependency injection. I apologize. This is not good. Can you see my mouse on here? Yes? No. In the top corner or the bottom corner? Okay. That's what I'm trying, but there's no awareness of the down arrow over here. Yeah, but when I hit the down arrow, it's not doing anything. On my computer, I'm looking at 2 slides ago. And if I do this, I skip a big chunk. Ha, almost. Okay. So, can you see? Okay. I'm gonna wing it. I'm sorry. These slides will be available so you can look at these chunks of code, and that will hopefully make it easier for you to understand what it is I'm saying. So we needed to bring in these new dependencies, the new code that we had written, and we needed it to be aware of all of that code's dependencies. So the dependencies are the objects that your class needs in order to function. We had something called a GPA service that looked up what the student's GPA was, and that information was used to decide if they were qualified for a scholarship. That's their grade, sorry. And you inject that dependency using like your constructor. When you're adding in its dependencies, you're building that constructor. And the dependency injection decouples your code from those dependencies in a way that you're not having to manage everything that your code needs. And you're not having failures at the time that someone is accessing your application. And when you're doing something like this, it's really important that you're able to bring in the dependencies along with the code you're working on. You want to instantiate your classes and dependencies and then those classes' dependencies. We had this file called bindings.php that managed all of those things. And you guys are not seeing it at all. But it basically would use the fully namespaced class that you needed and then create an array based on $container with the fully namespaced class path as the array identifier. And then included in a function, in a closure, all of those classes that it needed. That was how it was building on all of its dependencies. And this file was included in services.php, which I think, nope, you can't see that here. Sorry. So it was including those using services. Talking through code without the code is challenging. But let's see if we can do it. So we needed a container to be able to bring in those dependencies. And I think, oh man. So we had Pimple. We included this container using Pimple, and we identified it. We added it in our services.php file, which was part of CodeIgniter. It was how we brought it in. And we used that container to define a config, and we pulled in a config file, config.php, that just had an array of all of the settings that we needed. And because we were bringing this into the CodeIgniter services, we were able to reference those configuration variables and access them in our new code base as well as the old code base. So in the way that you're used to setting up that array with all of your database connections, we were able to set that up in our config.php file and pull that in both places and use the same database for both our new code and our old code. And we set up a lot of other things in that same space. And like I said, all of this will be available after. The services were hooked into CodeIgniter, but we also grabbed the new services we had created in our base controller class. There were certain things that we needed for things like authorization. Those we included into our base controller, and we initialized this container in the base controller so that we could always access this information. And then for our new controllers, if it was something that we needed throughout that controller, we would include it in the class that had the same name as the controller, if you remember when that was going on. And then if it was something you only needed for one controller method, we would initialize it there. And by initializing it, I mean that we would give it a local reference, like this GPA service equals $container, and the fully namespace path to that container. So after we did that, we were in pretty good shape because we had our new controllers. We were able to replace a lot of the old code base. And I felt like this was a really a big change for me in how I looked at legacy, because I was always looking at it from a perspective of, I have this version, and I need to get to this version. And with this project, I didn't even know what version we were starting with. It was really ambiguous. And it always felt like you just had a route that you couldn't find on a map, you know, to try to get from one to the other. But this gave some power with, no matter how old an application was, we could start replacing it in pieces, and we could make it aware of the new code without completely breaking ourselves. Okay, I'm hoping we're in the clear on this weirdness, because that was the one thing that I had built down. So we talked about the bindings file that defined all of our references to all of these new dependencies. We talked about the services.php and how that brought in all of our Twig connections, our databases, and everything that we needed to bring in, everything we needed to configure. And then our new controllers with all of that new functionality. And this code was, or this project was moderately successful. We had such a tight timeline to complete the work that we made a lot of mistakes, because DDD was entirely new to us. Event sourcing was entirely new. I remember we wrote this projection that didn't even make any sense. But we learned a lot, and we were preparing for the second year to spend some more time on it and improve some of the things we knew were really, really broken. And then we found out the university had decided to buy a product to replace it. So we didn't have to live with any of those mistakes, which was really nice and convenient. If you can work that out, I recommend it. Okay. So I think we did that part. Now let's talk about the student enrollment process. This was just a pretty simple application, but it was even older than the scholarships application, if you can believe it. It was basically the original way I remember writing PHP, where you included the header and the footer and maybe a menu. And all of it was done in includes. There's a huge functions.php file. It was great. And it had been maintained by the group themselves. They hadn't really had a software developer or anyone look at it in a really long time, and they had some issues that they were in over their heads, so we came in to help them. And as with most of our applications, they began with paper forms. You know, a student was applying to take a class, and they would submit this form on paper, and someone else would look at it. It went a little bit like this. They would bring their paper into someone sitting at a desk, and that person would decide, yes, you can take the class, or no, you can't. And it was very simple when it started out. But if you've ever built applications like this and then allowed them to continue untouched for a really long time, they start getting complicated in weird ways. Because they're updating a status as it goes through this process, and it's effectively putting a rubber stamp on it when it starts out. But then the process becomes more complex. And so they may start out with just an extra column to reflect the status, or they may put some related table that tells you what the status is of that application. But there start to be a lot of forks in the process, and a lot of conditions and additional steps. And that's what happened in this application. It just started getting really, really complex. And if it had remained a paper process, we would have ended up with piles of paper in these really haphazard ways, because that's how complicated they had made things for themselves. And it was really just a simple drop down like this. Like, how bad could that be? You know, we have an application. The student wants this class. How bad could that be? It could be this bad. There are 12 types of pending. And the thing is that there aren't 12 types of pending in a process. It's pending. But they started trying to tack on the reasons that it was pending to explain what was going on in the process, because there wasn't any wiggle room to handle that in their process. So it was unnecessarily complicated. And really, they're just trying to move these student requests through in the simplest possible way. Most of the students aren't on the same campus as us, so communicating with them online should make things a whole lot easier, but they've really made their process a lot more complicated. So what we started to do was recognizing these changes, these steps in the process as actual events, and interpreting those events to figure out where the request was in the process. And it was really tricky to talk to them about how their process was evolving, what was going on, but we were able to work through it quite a bit by separating the thing that actually happened from the result. Because a lot of what they were doing was passing this student and their request to someone else behind the scenes, and a student didn't need to know about that change. It was just some of the extra administration behind the scenes. But there were things that needed to be passed back to the students. So by looking at these as individual events, we were able to handle them in a similar way to what we talked about in the beginning, where as we're applying that event, we update information, and if certain events happened, we would notify students or notify administrators and pass that information back and forth. But they really needed to spend some time thinking about their process. And this type of thing happens in our applications a lot, trying to move through processes like this. And we were able to streamline quite a bit. But I'm really excited about the project that I'm working on now. And this is with Inquest, a network security company where I work. And this is a diagram of what our product does, and on the website it's animated, so it's really nice and flashy, but I mean, I couldn't even move through my slides right now, so it was good I didn't try to add animation. But basically, across the top there, you have your network traffic. And what our product does is it looks at that network traffic, analyzes it for known threats. We have security analysts who know the types of threats to look for, and they'll break it up into pieces so that we can continue to analyze it. After the first time it analyzes it, they give it a score. And someone who is using our product can look at the results over here where this user is. They can look at the user interface and see what type of traffic is coming in through their network, where are the biggest risk factors, what types of things they need to be aware of. And there's a lot of traffic. There's a lot of stuff going on and a lot of moving parts. And our product's not very old, but it has evolved really rapidly because it's in a part of the security market that doesn't exist. There's no other product, as far as I've been told, that does this. And it's really, really useful. But we're getting a lot of feedback from the people who are using it and changing rapidly. So we've got some schemas that are really complicated, and they're not built the way that we would build them today. But we also have several different pieces doing this analysis behind the scenes and deciding where the threats are. So it's kind of hard to change your schema when you have so many moving parts and when one small schema change affects 2 to 5 different code bases, depending on what it is you're working on. So we're trying to find a way of bringing in event sourcing to improve some parts. One of the main parts is our reports, because that's a big part of what we can let our customers know. In these reports, this one, for example, shows the top file types that have been causing problems. It's got a minimum threshold on the score. If we are capturing these threats that are detected in events, we can build projections based on them specifically for these types of reports, which would be really powerful. What we're doing right now is joining this complex schema that made sense at the time, but sometimes we can be joining about 7 tables, just trying to get all of the information in front of the user that they need to know. And it wouldn't be bad if we didn't have so many rows to represent every piece of traffic that came in. But we also have user groups that have different levels of permissions and different things that they're allowed to see. Because it's security, they really like adding a whole lot of complexity around what people are allowed to look at. So adding on this user permission level makes our queries even more complicated. But if we're throwing events, if this was our entire event store for all of the types of threats that we wanted to capture and wanted to record for our users, we could build a lot of different types of projections. We could build one for every type of report. And at the time that we're querying it, we can figure out what the user is allowed to see and then collect the results. But we're pulling that out of one table for each report. That is optimized for us to read instead of us trying to pull together all of the information that our engine has reported or recorded in our database. And it's really nice when you have a lot of different pieces of functionality, like if you're in a microservices environment, if you have a lot of different things going on, it's really easy for one part of your application to say, this event happened, and record it in a place that everybody can access, and then build that context based on what they understand that event to mean. So this could be really powerful for us, because we don't have to rewrite our entire schema and go through the changes that each of our groups would have to manage. We can look at these events, throwing them in places that are meaningful, build useful reports, and over time replace large pieces of our application by making them event sourced. And this could really improve our process. And so we're in the middle of working on this with our current release. And I think it will be really helpful. But what's also really helpful is that we can tiptoe in. We can do it in one portion of our application. I can ask the members of the engine team to just create those events when they find them. They can still add things to those 7 tables. They can continue doing things the way they have been. If they just create this event, I can start working on building up that history in the event store and with projections and start showing some real value. This is also really helpful in our environment because we're not allowed on a lot of the boxes that run our software. A lot of times when we're working with customers, we're talking to them and asking them to step through using our application. Having a really lightweight way to make changes to the way they're viewing data without losing the history is extremely valuable. So when our next update comes, they'll start being event sourced, and they'll start being able to see more information with events, and their queries are going to be a lot faster. And we can just do this in pieces through our release cycle. I think I've talked about a fair amount of that. We'll also have a lot of history, which can be really helpful also when we're trying to figure out what it is that's been going on in another environment. We can throw events that can help us debug a lot of things that have been happening in the application. I can't see my notes for how to say this, but I really appreciate your having me here, and I really appreciate your patience as I struggled with some of the technical difficulties. Like I said, I will share these online, and you can see the specifics of how we did our dependency injection in the original application if you need something like that. I have a few code examples from the events themselves. They're also in the slides. And if you want to talk to me about this or ask any questions, I would love to talk to you about it. Either now, we can talk about questions, or after the talk. Thank you.
Thank you, Emily. If you want to ask questions, we have 2 mics, so don't worry. Back rows, there's a girl with a mic. Anybody wants to ask a question? Okay, I'm gonna do it here.
Hi.
Hi.
Thanks for the great talk.
Thank you.
Do you have any recommendations on how to decide if a certain part of the application should be event sourced? Because in your example, sticking with 7 tables probably made sense when they started with it, and now event sourcing could be better.
Mm-hmm.
Do you have any recommendations when to switch?
Yeah. So most of these were kind of rigid points and difficult to change. And the event sourcing gave us a lot of power in adding something new and a new way of handling it. For this specific project, it really is because a lot of our database queries are really, really slow. And they're really slow for us with it's still a significant data set, but it's nowhere near the size of what our customers are dealing with. So we're not feeling the same pain that they are. And so finding those places where your queries are really big can save you a lot, because you're changing this to build information for you to consume later. You're thinking about what your users want to see, and the thing that you're building for them to look at can be changed. If, like almost every application that I've worked on, you build some sort of report of all of the transactions that have happened in the application, and they're always like, no, this is exactly the spreadsheet we want. It always starts out this way, and it's just this little thing, it's nothing, but it always grows. They want more information. Everybody always wants more information. So when you're flexible to changes like this, it's really powerful. So finding those places where your application is really bogged down, or places where it's really likely to change as more people are using it. Those, I think, are big indicators of where event sourcing can help you.
Okay. Thank you.
Anybody else?
Okay, well,
No?
Fala.
Okay. Thank you, Emily. Anyways, you can ask Emily anything in the middle track, since we have a break now. It's a break for refreshment. I see you here exactly 4 o'clock. 16:00 hours. See you here with new lecture. Thank you.